Welcome to the class of Advanced Stats and Econometrics. In today's lecture, we are going to discuss the remaining part of the discriminant analysis. Remember, we have already done stage 1 and 2. In stage 3, we will look at the assumptions of discriminant analysis, and the key assumptions are multivariate normality of the independent variables, equal variance and covariance for the group. Other assumptions are minimal multicollinearity among independent variables, group sample size is relatively equal, linear relationship, elimination of outliers. Stage 4 is estimation of discriminant model and assessing overall fit. Selecting an estimation method, simultaneous estimation, in which all independent variables are considered concurrently. That means at the same time you are including all and considering all independent variable, and stepwise estimation, in which independent variables are entered into the discriminant functions one at a time. Estimating the discriminant function. The stepwise procedure begins with all independent variables not in the model and select variables for inclusion based on statistically significant difference across the groups, that is 0.05 or less required for entry, and the largest Mahan-Lobis distance d square between the groups. So Mahan-Lobis distance is a statistical measure of distance in which you look at you consider the correlation you take correlation into account while considering the distance, calculating the distance. Assessing overall model fit, calculating discriminant z-score for each observation, evaluating group differences on the discriminant z-score, and assessing group membership prediction accuracy. Assessing group membership prediction accuracy, major considerations are statistical and practical rationale for developing classification matrices. The cutting score determination, construction of the classification matrices, and standards for assessing classification accuracy. Model estimation and model fit. Although stepwise estimation may seem optimal by selecting the most parsimonious set of maximally discriminating variables, beware of the impact of multicollinearity on the assessment of each variable's discriminatory power. Overall model fit assesses the statistical significance between groups on the discriminant z-scores but does not assess predictive accuracy. With more than two groups, do not confine your analysis to only the statistically significant discriminant function, but consider if non-significant functions with significance level of up to 0.3 add explanatory power. Calculating the optimum cutting score. What are the issues? First, define the prior probability based either on the relative sample size of the observed group or specified by the researcher, either assumed to be equal or with values set by the researcher, and calculate the optimum cutting score values as a weighted average based on the assumed sizes of the group derived from the sample sizes. So optimal cutting scores with equal sample size. You see group A and group B, and ZB bar are the mean. So classify as A and classify as B. Purchaser is B, A is non-purchaser. An optimal cutting score is shown like this. So then you can see that a part of group A is lying here and a part of group B is lying here. So if score is greater than that, it is purchaser. If a score is less than that, it is classified as non-purchaser. Optimum cutting score with unequal sample size. If the sample size are different, then you have to select the weight, optimum weighted cutting score, unweighted cutting score. You need to change and you need to move to optimal weighted scores, and then you will see the interaction between group A and group B is like this. Establishing standards of comparison for the hit ratio. Group sizes determine standards based on equal group sizes, unequal group sizes. Then there are two criteria for unequal group sizes. One is maximum chance criteria, second is proportional chance criteria. So classification matrix or confusion matrix, HBAT new consumer product. So actual group and predicted group. Actual group are 1 and 2, and predicted group are also those who are likely to purchase and those who are not likely to purchase. So 25 observations predicted groups are like this. They predict that 27 will purchase and 23 will not purchase out of 50. Those who are likely to purchase according to the predicted group are 27, but out of those 27 only 22 actually purchase and 7 are misclassified. So similarly, those who are not likely to purchase was 23. Out of those 23, 20 were correctly predicted that they have not purchased and 3 have actually purchased. So the data is showing that out of 50, 42, 22 and 20 are correctly classified. So 42 out of 50, that means 84% is the hit ratio. So percentage correctly classified is called hit ratio. Assessing predictive accuracy. The classification matrix and hit ratio replace R square as the measure of model fit. Assesses the hit ratio both overall and by group. If the elimination and analyze analysis samples both exceeds 100 cases and each group exceeds 20 cases, derive separate standards for each sample. If not, derive a single standard from the overall sample. Analyze the misclassified observations both graphically, that is territorial map, and empirically, that is Mahalanobis distance d square. Okay, assessing predictive accuracy. There are multiple criteria for comparison to the hit ratio. The maximum chance criteria for evaluating the hit ratio is the most conservative, giving the highest baseline value to exceed. Be cautious in using the maximum chance criteria in situations with overall samples less than 10 and or group size under 20. The proportional chance criteria considers all groups in establishing the comparison standard and is the most popular. The actual predictive accuracy hit ratio should exceed any criteria value by at least 25%. Stage 5 is interpretation of the results. Three methods are there: standardization, discriminant weights, discriminant loading, structure, correlation, and partial F values. Interpretation of the results. Two or more functions. Rotation of discriminant function, potency index. Graphical display of discriminant scores and loading. Territorial map is most common method, and vector plot of discriminant loadings, preferably the rotated loading, that is equal to, that is basically the simplest approach. Plotting procedure for vectors, 3 steps. Selecting variable, stretching the vectors, and plotting the group centroid. So here you can see territorial map for 3 group discriminant analysis. X1 is customer type. So group centroid is shown here. So there are 3 groups. One is uh, over 5 years, customer who are like customers since last 5 years or more, and then who are customer from 1 year to 5 years, and less than 1 year. Less than 1 year is shown in red triangle. 1 to 5 is in green circle, and over 5 years are shown in blue squares. And group centroids for these 3 are marked in pink. You can see that function 1 and function 2 are the x and y axis, so there is a difference between the observations across group, and that is shown through territorial map. Interpreting and validating discriminant function. Discriminant loading are the preferred method to assess the contribution of each variable to a discriminant function, because they are a standardized measure of importance ranging from 0 to 1, available for all independent variable whether used in estimation process or not, unaffected by multicollinearity. Loading exceeding plus minus zero point 0.4 are considered substantive for interpretation purposes. Interpreting and validating discriminant functions. If there is more than one discriminant functions, be sure to use rotated loadings. Assess each variable's contribution across all the functions with the potency index. The discriminant function must be validated either with a holdout sample or one of the leave one out procedure. Stage 6 is validation of the results, and it has two parts: utilizing a holdout sample and cross validation. And the reference for all this is a book titled Multivariate Data Analysis 8th edition Cengage Learning, and the author of the books are Hare, Babin, Anderson and Black. And that's it for today's class. Thanks.